Good evening. The Tuggerah Wastewater Treatment Plant is located on the central coast of New South Wales, approximately 45 minutes north of Sydney. It operates 5 days per week with 3 staff on site and on-call coverage weekends and after hours. Preliminary treatment comprises a head of works, step screens for rag removal, grit removal via a circular auger. The next step is odour control, where sulphides should be managed. However, this part of the plant is inoperational and has been offline for an extended period of time. The poor management of sulphides is manifested not only in odour, but also corrosion of key metal elements, including ladders, on the head of works. Wastewater is then piped into a flow splitter and onto combined aeration and settling ponds. There are 4 in total, with each holding 6 megalitres. They operate in pairs, with 2 aerating and the other 2 settling. The aeration keeps solids in suspension and allows for microbial treatment via metabolism of organic waste. Ammonia is converted into nitrite, then nitrate, and finally nitrogen gas, where it bubbles out into the atmosphere. Ammonia is typically 36 milligrams per litre when it comes into the plant, and is reduced to between 0.1 and 0.3 milligrams per litre after digestion. Each cycle of duration is 90 minutes. The aerators are switched off to allow for settling to occur. Because the tanks are paired, this provides redundancy for maintenance in the event of unplanned outages. Note the flock in the foreground of this image and the aeration in the background tank, tank 1. All of the processes are controlled via SCADA. At this stage of the process, the flows are split, one into activated sludge stream and the other into wastewater. Let's follow the sludge process first, highlighted in the brown on the flowchart. This process occurs mainly within the building in the background. First, the sludge is transferred from the bottom of the settling tanks into the waste activated holding tank, or WAS tank. This is continually stirred and then decanted into the dewatering shed. In the case of failure, this flow is diverted into 3 defunct sludge lagoons before being recirculated through the preliminary treatment and usual process cycle. Next, it is transferred to the dewatering shed, where polyelectrolyte is added to aid the dewatering process. Mixed liquor solid settleability target is 2,500 with an allowable range of 0 to 5,000. The sludge is deposited onto a belt press where water drips through the screening holes on the belt. The sludge is then compressed into a cake before being transferred via conveyor to semi-trailers for disposal. This has various purposes, from bush and land regeneration to compost at nurseries or combining into agricultural lands as fertiliser. Returning to the wastewater process, the blue flowchart, water is passed through a chlorination transfer well. The chlorine is stored in a secure space in a separate building according to Australian standards and best practice. Final step is pumping the treated water to the dry weather tank for retention and further nutrient catabolism. It then flows into the wet weather pond prior to being pumped to ocean outfall at Toukley. The wet weather pond holds around 200 megalitres, and there is also bypass options available which skips the dry weather pond direct to the wet weather pond in the case of an overflow from an extreme weather event. The limited amount of water is recycled via the reclaimed water plant, but use is strictly restricted to on-site purposes associated with irrigation and plant maintenance only. Final effluent is discharged via Toukley Ocean outfall. Thanks and acknowledgement to the Water Education Officer at Central Coast Council, Mr. Dylan Margin, for facilitating and conducting my tour of the treatment plant. It is a robust process. The opportunities for improvement include remediating and restarting odour control, improving sulphide management at the head of works, and future-proofing the Central Coast water security via a formal wastewater reuse program, including social licence, to bring in effluent standards up to the potable water quality requirements. Thank you.